Following on from the previous video, we've established that the quadratic approximation for a given complicated function. Let's say you've been given this complicated function here. The quadratic approximation to this complicated function here is given by this. So you will need to work out the normal f of x evaluated at x equals 0 here, and then you need to work out the derivative here. Evaluated at 0, and then you need to work out the second derivative here, just in order for you to work out the coefficients. So here this is a coefficient of x here. This is a coefficient of x squared here. So you need to work out the first derivative. You need to work out the second derivative. And then you need to work out the normal function evaluated at x equals 0. So basically, in order for you to find out the quadratic approximation, you need to find out these coefficients here. Okay, so let's just say you've been given this here, and we have to try and work out the quadratic approximation to this. So we need to work out f evaluated at 0. We need to work out this f prime evaluated at 0, and then we need to work out this, and then later on we can then divide it by 2. Okay, so we need to work out f prime, and then we need to work out f double prime of this, just in order for us to work out the coefficients here. Okay, well, anyway, let me just give you an example here. So given this here, let's try and work out the quadratic approximation. So first we need this we need this here. So we need to evaluate this at x equals 0. So put 0 into here. Okay, so our aim here is to work out the quadratic approximation for this here. So we need to put 0 into here. When you put 0 into here, it really becomes 0. Okay, so f of 0 is 0. So this here, this box here will be 0 later on. Okay, now we need to evaluate the first derivative now. Okay, so now let's find the first derivative. So when given this here, differentiate it once, that will give you your first derivative. So when you differentiate this, it will give you this. Now that you've got the first derivative, evaluate it at x equals 0, meaning you put 0 into here. Well, when you put 0 into here, then this whole thing here will be 1. So going back to here, this box here will be 0. This box here will be 1, meaning we're going to later on, we will have 1x, which is just x, and then plus. Now we've got to work this out. But just concentrate on finding out the second derivative. Later on, we can divide it by 2. So our next aim here is to work out the second derivative here. Okay, so this is this is our first derivative. Now we need to work out the second derivative. So remember that this is our first derivative. We now need to work out the second derivative. So rewrite this as this to the power of -1, and then we can just differentiate this. Okay, so when you differentiate this here, the -1 goes down, and then the power itself gets minus by 1. Okay, so when you differentiate this, it will then give you this. But then we need to evaluate it at x equals 0. Okay, so once you're here, tidy up, and then that will give you this here. And then we need to evaluate it at x equals 0. So we've got to put 0 into here. So when you put 0 into here, f double prime at x equals 0 is -1. Okay, so now given this formula here, we've established that this here will be 0. This here will be 1. Okay, this here will be 1, and then just this box here will be f double prime here. Just that box there will be -1. So just this box here, it will be -1. So don't forget the 2 here is going to be here. Okay, so this term here goes. And then here you've got 1x. That's this 1x here. And then remember that this double prime here is -1, meaning that you're going to get -2 because of this 2 here, and then x squared. So this here, so whenever you have this thing here, you can approximate it to this. Okay, so this is your quadratic approximation near x equals 0. Okay, so looking at the graph here, if you get a graph plotter, your quadratic approximation, which is this blue line here, you can see that around x equals 0, it is quite good. It is a good approximation. Okay.